Hello everyone and welcome to today's webinar, the second webinar in our series on error proofing and how we can implement that into our manufacturing processes. So we do have one additional webinar coming up, and so please feel free to join us for that one. We'll have a little bit more information at the end of that. So for this webinar, everyone's mic will be muted. However, that doesn't mean you can't participate in the conversation. Feel free to use the chat function. You can ask questions or make a comment, and we'll be looking at those at the end for the Q&A section. So please feel free to use that. So I just want to say before we get started, thank you very much for joining us. I know your time is valuable, and I hope there's going to be some information in this webinar that you will be able to use and take away in your manufacturing processes. So to begin, my name is David Cash. I've been with Mountz now for 15 years, in the torque industry for nearly 20. I started at Mountz as a territory sales manager. I've had the opportunity to see a lot of interesting applications and very challenging ones as well. So I really enjoy working in the torque industry, and especially working for Mountz. Now, Mountz was founded in 1965 in San Jose, in the heart of Silicon Valley. We were the first company to develop an electronic torque tester for the military, so we have quite a bit of experience with that. We have a distribution and warehouse facility and service center located in Foley, Alabama on the Gulf Coast as well. Now, when we talk about today's topic in error proofing, to kind of piggyback on our last webinar, the topic or the idea of error proofing comes from the Japanese manufacturing process of Polka. And basically the Polka is a way to mistake proof or help to prevent inadvertent errors in whatever process that you might be looking to accomplish. This transferred into lean manufacturing, but in its essence, it is a way to shape behavior and provide constraints on the operator or on the user to make sure that they aren't committing an error, and trying to help prevent that. So the three of some of the ideas or topics on Polka are facilitation, detection, and prevention. Now, facilitation primarily is dealing with notifying the operator or the user via either a sign or work instructions to that effect. Detection will actually detect when there is an issue or an error, and then you have the opportunity to fix it. And then prevention helps to make sure that the operator or user can't make a mistake in the first place. So all three of these really help to shape the Polka, and if we look at Polka in everyday life, we can certainly see that in the cars that we drive. You must start the car in either park or neutral, or with today's keyless cars, you need to have your foot on the brake as well before you press the start button. And obviously this is a safety measure to help protect people that are around the car when it starts up. You can also see it in our homes, in our appliances, where we have a door function that needs to be closed before the appliance will start or be able to be used. And then we can also see it in when we fill up our gas at the gas pump. So the nozzle will detect when the tank is full, and automatically shut off, helping to prevent any type of overflow or spill that might happen with the gasoline as we're filling up our cars. So those are just kind of some examples of how that may happen in our everyday lives. Now, when we look at the manufacturing process, what are some of the risks that are associated with torque, and more specifically, how that deals with improper torque control. So if we look at some of the challenges that are facing us as it relates to torque control, first is over torque. If we do have any type of over torquing issues, that can be a real problem. Obviously, you may have a simple fastening application. However, if that fastener is over torqued, you're putting the joint into almost a yield situation where that fastener could fail, and then you may have issues with rework as well. So over torquing is a big issue that we see in our industry. Also, we see either incomplete fastenings or missed fastenings, where you may have fasteners that aren't completely torqued and they are lifted heads or lifted screws on the application. And this may be due to a number of reasons. Perhaps the operator is trying to move through the operation too quickly and doesn't detect that the torque outcome has been completed. We also see cross-threading as an issue. Now, with cross-threading, the torque will be achieved. However, the fastener obviously won't be seated correctly. We can also see it with the operator, the human component to the torque challenge. Again, the operator may feel that tight is better, and that if they have the opportunity to make sure that the fastener is good and tight, then that may cause some issues as well. So shaping the behavior with the operator is certainly a risk to the improper use of torque control. Being able to collect data on the fastening for either a review of a part or a component may be a challenge for us as well. Also, the ability to train operators correctly on how to use tooling that's been given to them is also a challenge for us as well. So right now we'll go ahead and take our poll, and I'll give you a few minutes here. The poll is, what we're asking is, are you currently using sequencing to do and complete your operations? So we'll give you here just a few minutes to go ahead and take that poll, and we'll discuss the results here in just a second. All right, so it looks like a little bit more than half are using some type of sequencing to be able to complete your manufacturing assembly process. So if we look at what are some of the challenges as it relates to sequencing, first of all, if we're dealing with any type of a gasket or flange type of application, the way to be able to seat that fastening correctly definitely depends on using sequencing. You don't want one side of the flange or the gasket to be compressed and the other side not fully seated as well. Obviously, that can cause issues in a gasket type application. The other thing, one of the other challenges that we might be dealing with is relaxation in a joint. This could be also from a gasket or some type of washer type of application, where as soon as the joint is compressed, you get an immediate relaxation in the fastening. So that may require some additional torquing, but that could be a challenge for us as well. An additional challenge in sequence tightening is going to be the use of different joint characteristics within a certain assembly sequence. And so the coefficient of friction may be different in different fastenings within that same sequence. So how can we go ahead and make adjustments to the sequence to be able to overcome the additional forces or a different coefficients of friction that may be evident in there in that specific assembly. Also, there may be different size fasteners within a certain assembly. How can we account for that and make sure that we're not using the wrong fastener in the wrong location? Especially if the fasteners may be very similar as far as the head size may be, but they may be different lengths. And putting the wrong fastener into a wrong area that may cause damage may be a concern in dealing with sequencing as well. So how can we safeguard against these tightening failures? And I wish it was just as easy as putting on a mask and putting on some safety glasses to be able to help safeguard us, especially in this climate as we're dealing with some medical challenges as well. But so what are some of the things that we can do to help safeguard us in dealing with sequencing tightening failures? So first, if we have tools that we can go ahead and deploy that are equipped with error proofing type of capabilities, this is certainly going to help us. If we have the ability to track each screw during the operation, so we have to make sure that the specific data that we're collecting for that specific fastener is something that we can do, and we can be able to record those events when there. We can also use this to help eliminate any type of operator influence in the sequencing. So we can use torque control systems that are going to be precise, they're going to be accurate and repeatable, and we have the ability to detect an error when it's possible. And so how can we go ahead and make sure that we can use these types of safeguards in the sequencing process? And the answer is to be able to use a position control system that will allow us to be able to apply power to the tool when the operator is in the correct location. And then this can help us guide the operator through any type of sequence. So the operator must follow this sequence to be able to complete the operation. Now, there are a number of different position control systems that are available out on the marketplace. So we'll just kind of touch on generalities here, and then we'll talk a little bit more specific about the Mountz solution and what we have available. But again, these help to eliminate any type of rework because of the fact that we're having the operator go in a certain pattern. We're not missing fasteners that are being attempted. And then we're also allowing the assembly to basically have a quality control on the assembly line. Oftentimes, the positioning control systems are used with torque arms, and the torque arms are then equipped with encoders and things, and we'll talk about that here in just a second. But some of the advantages of using a torque arm are they're going to help reduce any type of repetitive motion injury in the area for the operator. So the torque arm will absorb any type of torque reaction that the operator may feel when a tool shuts off, especially in either an electric style tool that may be a little bit higher in torque values, that you can go ahead and absorb that shock and that reaction then stays in the tool on the torque arm. This helps to prevent any type of carpal tunnel or additional medical type of injuries that you may see from the use of torque tools in general. These tools, as I mentioned, are equipped with encoders, and this allows us to be able to track the tool as it moves in space, and then the system will modify its settings based on the location. So for the Mountz torque arms that we have, this is one of our most popular units as it relates to airproofing and the smart controls. It comes with 2 encoders. We have one encoder at the articulation point in the arm, and then there is an additional encoder at the top that monitors the rotation of the entire arm assembly. Now, the use of these 2 encoders helps give us a relation in space where the tool is. The arm itself can also be adjusted so the tool can come down a little bit. The arm there can be set to move at the articulation point down 22.5 degrees or 45 degrees from that pivot point as well. These particular tool or torque arms have a capacity of up to 100 Newton meters in their standard configuration. We can also use go up to 500 Newton meters for either a floor mounted model or an additional modified style of arms. There's also a telescoping positioning arm that's available. These are equipped with either an angle encoder that monitors the tool from the base of the joint where the arm is mounted. It could also be equipped with a length encoder, so we can monitor both the angle and the length to give us our position. Now, depending on the application, you may only need to use one of those 2 encoders, either the length or the angle, or we can combine both of them in there. These have a standard torque capacity of up to 300 Newton meters, and we have lengths that can handle up to 3 meters in length for the telescoping arms. Now, the DPC Touch POSI control system uses 2 components. We have the arm component, and then we also have the controller. The controller helps to guide the operator through the sequencing process. It also has the ability to manage a number of peripheral devices that we can use to help use with the overall process. So it can communicate with a PLC, or it can also function as a PLC device where we can use it to add peripheral devices to the assembly process. So what are some of the items that we can use in communication with the positouch controller? The first is going to be proximity sensors. So we can use those in a case where we need to detect that the part is in its certain position. We can also use barcode scanners to select different programs. So if there's a high mix, low volume type of assembly process, and there are a number of different assemblies that may be needed, that is a possibility to use that. We also have the use of pick-to-light sensors to help, again, guide the operator through the assembly process to make sure that they're using that specific fastener. You can use screw presenters to be able to do that. We also can implement light trees. So the touch system allows us to basically put a quality assurance on the assembly line. So we do have the ability to monitor each fastening that takes place, and we need to make sure, or we can ensure that the operator is moving in the correct sequence that we need them to do. This helps us to be able to prevent a lot of additional costs associated with either programming a PLC and to do that, but we do have that ability to monitor the operation. So as the system works with the assembly process, we do have the ability to interact with digital IOs that are all assignable. There are 12 inputs and output signals available that we can use with that. And you saw that in the video represented in different steps. So when we place the workpiece in the tray, we have communication between the proximity sensor that sends a signal to the controller. And once that step is complete, then it sends a signal to the locking mechanism to go ahead and secure the lock. Then we move into some of the fastening componentry of it. And again, there's no power to the tool unless the operator is in the right position during the fastening step. So we can really help to prevent any type of missing fasteners within a specific assembly process. And we can make sure that every fastener is torqued, but not only torqued, but it's torqued correctly because of the way that we can monitor the system. So this helps give us, again, the ability to detect any issues as they happen, and they can be corrected right away. This gives us the quality assurance that we need on the assembly line, and the system itself can be integrated with other manufacturing devices to help move us into the Industry 4.0 fastening. Okay, now if we look at this basic assembly process, we have our DPC Touch here telling us which fasteners we need to go ahead and run for our assembly, and it's giving us the visual guide on where we need to go. So we have our first fastener here in this location, and associated to our thread block, that's going to be this fastener here. So to begin, if I try to start the tool, I don't have any power whatsoever, but once I get into the right location, I now have power to the tool, and the system will go ahead and index to the next step, or in this case, our next fastening, and that's going to be located here on this fastener. So we can simply run through the application, and it will go ahead and index to make sure we have the correct fastening. If we aren't in the right area, the right location, the operator can't make a mistake in the assembly process. So once we get to the right location, we can go ahead. Now that job is complete, and the system will reset the application to be able to run that specific assembly again. Now, for example, if we had a system where we needed to be able to do some rework on a part that had some fastening errors or some other type of rework, and we needed to do some removal of fasteners, we can do that in a specific program. So if I use the barcode scanner, and I can scan, and it went ahead and changed to a different program that we have set up in the job manager on the DPC Touch. So at this point, we can now also loosen these fasteners in any order. I'm using a special setup on our and then the system will go ahead and start for the next assembly. So if we want to take a look at some of the additional features that are within the Touch. So you can see in our application we had a total of 4 fasteners here. Currently we've done 0 because we've reset that. But you can see over here shows our location data. And as we move the tool in space, you can see that the different areas will go into basically an OK zone, and then the fastening zone. Once we get both encoders into a green position, then we now have power to the tool. The system itself can have up to 4 different encoders. That's why we see the other 2 boxes there with some data in them. So again, this is how we can control the tool. The encoders themselves run in a 360 degree pattern. Each degree has 100 points of resolution in it. The system itself is accurate to within 0.09 angle of degrees. So it is very, very accurate, and we have the ability to control a very, very tight window for different types of fastening assemblies. So if we take a look at this specific program and how we made it, we can do that by going into our job manager, and we can log into our system, go to our job manager, and this is where we keep all of the different assembly processes that we have available to this particular unit. All of this data is stored on an SD card that allows us to be able to add images, add messages, and it basically will allow you to do a backup of the system by just simply copying the SD card that's in it. So if we look at our specific demo that we did here, and we'll go into edit, you can see we have the ability to program these different steps within the assembly. So our very first step is a message step, and this is giving us the direction on where the operator needs to be to go ahead and do their fastening. So if we take a look at what that looks like, here's where we would select which image that we want to use, and we can go through and we can select our different values or different images that we have in here. So if, for example, this was on this engine that we wanted to use, we could go ahead and we can use that as our image to help guide the operator to the correct location. We do have templates available to be able to make the image creation very, very easy to do. So that is a possibility for us as well. The next step here in our process is going to be our fastening step. This is where we have the location data that's stored for the fastener. So let me see if I can zoom in here just a little bit to make this a little bit clearer, so you can see what's happening. So right here is the location data that is saved for the first fastening in the system. We have our zone tolerances here. So anything within 35 points of this value is going to give us a good signal for being able to have power to the tool. So if I move the tool into that location, these numbers here will go ahead and correspond here, and we have our excuse me, we have our location. So if we needed to do any type of editing to a fastener, say we wanted to change the order of it, or we needed to update location, all we need to do is come into the pattern and edit this location, and we simply hit apply, and now it's going to update that location, and then we would save it, and the program has now been edited to be able to do that. Some of the other examples that we have for our programming, if we look at the example in the video that we watched, you'll see our very first item that we had was that we needed to go ahead and press our start button to begin our program. So that's our very first step in the program. Our next one was an input step. So the system is waiting for an input signal to come into the controller, and then it will allow it to move on to the next step. So we have our basically our logic input step here. And if we look at what that looks like, we have our input 8 checked in here, and it is an active high signal. So once the system sees that in this particular step, it will go ahead and say, okay, I've finished that step. I can go ahead and move on. In the same as a logic input, we can have an output. So in our situation where we had our message that showed to load our workpiece, once that happened, we have our input step that's going to sense the part is there from the proximity sensor, and then we'll have an output step which is going to fire the lock mechanism on the board, and that is accomplished by our output on pin number 9 or output number 9, and that is sent as a pulse signal. So you have the opportunity to have it set at a pulse or a continuous signal for the output, and we can control the duration of that pulse as well. The additional item that we have available for our programming is we can throw in a delay step, and you can see that is right in between the step here that we have for our input. So once the workpiece is sensed, we have a delay in here for 1 second. That is to allow the operator to make sure that there's nothing in the way, or this gives us the ability to add a 1 second delay in between the part being sensed and then the lock mechanism being fired. And then, so this kind of is the building blocks that we can use to set up a specific program that we have available to create. Now, the system itself can hold up to 255 different jobs, and within each job we can have we can have up to 999 steps. Within one fastening step, we can have up to 99 different fasteners, and that would be used in our non-sequential type of fastening with that. So that's our system. Let's go ahead and see if we have any questions.
Okay, we got a couple questions. We'll keep it short since we're over on time. First one is there a torque application where joint relaxation would not apply or occur?
Yes, you would definitely see a situation where there is not relaxation in what is typically called a hard joint. So that would be two surfaces that when they mate together and then the final torque is achieved would be less than or close to 30 degrees of additional angle or rotation. So that would be like a metal on metal surface without any type of washer or gasket. In those types of situations, you wouldn't see any relaxation.
All right. The next question is more of an application one. I think I'll try to summarize it. It's can the position control arm system be used with a hand multiplier and a click wrench?
As long as we have the ability to have a signal that we can use to control during the input and output section of the communication device on the DPC Touch. So if we are using a torque multiplier and we have the ability to monitor when that tool is running, when the tool has shut off and torqued correctly, then we can associate that with the DPC Touch. Now, as it relates to a click wrench, currently you cannot interface with that. However, we could input a step that would allow you to be able to use an additional input device, say maybe a switch or a button press, then that would confirm that the operator has completed the operation for a click wrench. So if that's part of the work instructions, it could be as simple as that. Or if we have the ability to attach some type of signal to that tool to know when it has clicked, then we can incorporate that into the work instructions or the steps within the DPC Touch.
All right, thanks. Next question. Is sequencing important in all applications, like an anchor bolt embedded in concrete?
Sequencing is really, really important in critical type of applications where you need to be able to seat something correctly. If the application is not demanding of a sequence, it may not be necessary. But if you are putting anchor bolts into concrete, it depends on what those anchor bolts are anchoring. So if you want to make sure that things are being seated correctly, you may want to use some type of crisscross pattern or star pattern that would allow things to be able to seat correctly. So whenever you need an item to be able to make sure that it is tightened to whatever part or board or substrate that you want, and you want it to be done evenly and correctly, you can employ sequencing to be able to do that more effectively.
Okay, thanks. Next question. Is it possible to expand IOs to a larger number? Can an operator leave any comments during the sequence if anything happens?
Well, we have the ability to use the 12 inputs and outputs that are available. We do have the ability to expand the use of signals through an IO box that we can add to the controller for the wiring capabilities that are essential. But we have 12 inputs and outputs that we can use for the DPC Touch. As it relates to comments, we currently don't have that functionality to add a comment during a rundown or during a manufacturing sequence. So that is something that is not available.
And that's the last question, Dave. No more.
Awesome. Thanks, Chris. And thank you for all of your questions. We do have the last installment of our series coming up, where we'll be touching more on the COVID-19 requirements as it relates to manufacturing. And we will be sending out a survey that's asking you on some of the procedures that you may have to take in being able to implement your manufacturing processes to satisfy whatever requirements are maybe deemed for you. And we're going to be sharing those results in our next installment. So that is coming up on June 18th. We'll begin again at 12 Eastern, and we would invite you to come back for that specific webinar. Again, I just want to say thank you again for your time. Really appreciate it, and I hope you have a great day, and thank you so much.